Anyone's here now, what we do is we read philosophy papers, try to explain them. Generally, I'm not sick when I do this because it's actually very hard for me to stream, read, and figure out philosophy at the same time. I know I've been doing this for a while, so it may look easier than it is, but it is not, and I'm not at 100%. So what we're going to do now is attempt to read Time for Curry by J.C. Beall and David Ripley. These are logicians. These are metaphysicians. These people generally know what the fuck they're talking about. We're going to go try and figure it out. I don't know. So, and this is a short paper, and this is for Yovko's birthday. Happy birthday, Yovko. I don't want to know anyone's birthday in here, because this is an 18 plus stream, so don't be fucking telling me. And if you are under 12, you definitely don't say you're under 12, because that will get you kicked off Twitch immediately. Because there's a 13-year age cutoff. So never say you're under 12. Yeah. So here we go. Time for Curry by JC and David. This paper presents, and as always, feel free to ask questions along the way. Who the fuck knows if I can answer them today? Luminance, what's up? How you doing? This paper presents Luminance. We shout out the Luminance. Luminance Bloom is also a streamer and a philosopher. Go give him a follow if you like philosophy streams or you talk about stuff. Give him a follow. Hang out. Spring break, so that will be chill. Nice. This paper presents a new puzzle for certain positions in the theory of truth. The relevant positions can be stated in a language including a truth predicate T and the operation square brackets that takes a sentence to names sentences to names of those sentences. They are the positions that take the T schema A if and only if T of square bracket A to hold without restriction for every sentence in the sense A in the language. Okay, so this is, I don't normally read logic on stream because there's a lot of shit to explain if you don't know the background, but like I said, we're doing this for Yovko's birthday and it's a short enough paper and I actually know this stuff, so I will try to explain some of this. So truth is said to be, at least in analytic philosophy, Luminance, Bloom, cover your ears, transparent. Transparent truth is this very, very thin theory. Truth is almost irrelevant in analytic philosophy. So if you say something is true, like I'm holding up my hand, you can say it's true that I'm holding up my hand and I'm holding up my hand have the exact same content. Saying something is true doesn't change what you're saying is true. Just saying it's true is actually nothing. It's just kind of like emphasis. And emphasis doesn't have any content. That just means you really, really like what you're saying. But who gives a fuck if you just really, really like what you're saying? So the idea that you say anything true, it's a very minimal, thin theory of truth. But this is a logical property representing that. So if you say something's true, some A, and then you say true of A, it's saying the same thing. So that's what this formula here says, that truth can just be dismissed, basically. Oh, Luminance is playing both sides? Okay, just promiscuous. Man after my own heart. Okay, so, yeah. There's the transparency of truth, which people in analytic philosophy and logicians really like. As such, they must be, you know what we can do? We can do that. As such, they must be based on a non-classical logic, since paradoxes that cannot be handled classically will arise. The best known of these paradoxes is probably the liar paradox, a sentence that says of itself only that it is not true. But our concern here is not with the liar. Instead, our focus is a variant of the Curry paradox, a sentence that says of itself only that if it is true, everything is true. Yeah. So, they'll get into it, I'm sure. I mean, I was going to say something about it, but they're going to explain what they're talking about. They have to. Section 1 is necessary stage setting. We present the standard version of Curry's paradox and the strain of response to it we wish to focus on. This strain of response crucially invokes non-normal worlds at which the laws of logic differ from the laws that actually hold. Okay, this is interesting that they're straight up saying that there's laws of logic which are different from the laws that actually hold in our world. A lot of people will say, look, laws, like the laws of logic may be more complicated at our world, and we only use a certain subset of them, which like kind of corresponds to classical logic. But they're just saying, no, these are foreign logics that don't hold at our world. Unreal says that the curry paradox, if there's infinite curry, but there is a curry spicier than all other curries. That actually is true. That's like, if this sentence is true, then there is a curry spicier than all other curries, is an instance of the curry paradox. And it would be true that there is a curry spicier than all other curries. Overwatch emote, let's go. Okay, in section 2, we go on to argue that in light of the temporal curry paradox, a novel version of curry paradox that they present here, this strain of response ought to also accept non-normal times at which the laws of logic in the actual world differ from the laws that hold now. We then consider section 3, what this would mean for the theorist in question. Energy. This is interesting, energy diameter, because I was talking about non-classical temporal theories. These are people in this area that are talking about non-classical metaphysics and temporal theories. So we were talking about this a few weeks ago. I'm if I have time, I'm going to try to write it for the due date at the end of August. But like, this is exactly the sort of stuff that may end up in that collection of papers that I'm going to try to get into. So we'll see. I don't know if I'm going to be able to pull it off, but if I'm not that busy in like July and August, maybe I'll write something. Okay, the state of play. So this is all background stuff. 1.1 Curry paradox. By the usual diagonalization methods, there is a sentence C that is equivalent to the truth of C implies false. So that means it implies anything. It's just explosive, where the arrow is the detachable conditional in the T schema. And this is why I don't do logic, because detachable just means it's regular old modus ponens, where you can have if P then Q, P, therefore Q. And so what happens is the P detaches, or the Q detaches from P. I forget what they say, but that's the whole point. If you have if P then Q and then P, you can detach the P from the Q, you know? And so that's modus ponens, and that's what this arrow is. So you don't need, the actual rules can matter a lot about the arrow or the implication sign, whatever you want to call it. But like, this is what basically is happening. You've got two things that are related, P and Q, and there's an arrow between them, and then you can break them up somehow. Okay, here they take false to be an explosive sentence from which everything follows. It might be that everything is true or some such. Given these resources, a proof of the T schema to falsum threatens. All right, so explosion threatens where if and only if is defined via the usual stuffs. Okay, so we're going to talk a little bit of logic here. So we're going to say C is the curry thing. So the truth of C, if and only if C. So if the curry sentence is true, then the curry sentence. Sure. And vice versa. Substitution. So you can put C in for the truth of C. And so, or no, you're going to substitute C and then, okay, so curry sentence also says if this sentence is true, then it's false. So you're substituting in the definition of the curry for the curry sentence right there. So then you've got, from the biconditional, you get the regular conditional, and then this is a known truth. It's called contraction, where if A implies B, then you just get B. So you just are gonna get yeah, you're just contracting from 3. So you drop off the first implication, and then substitution on 4 because that is just C, and then you've got modus ponens on 1 and 5. So C here from C implies that. You get this, and then you've got 4 and 6 implies falsum, which is just explosion, anything. So this is a very standard way to get a paradox using the curry sentence. Yeah, exactly, Yovko. That's contraction. So I mean, I was jumping because I didn't know what rules they had, but like, yes, it was just plain old contraction. You don't need if A then B, just be if A then B. Okay, but like, that's all background stuff. You can derive it in multiple ways, but that's a standard way. Here, the step from 3 to 4 is justified by contraction. Can we conclude from A implies B? We can conclude A implies B. Since substituting equivalents, eliminating ands, and modus ponens all seem like surer steps than contraction, one plausible way to treat this paradox while retaining the T-schema is to provide a theory of arrow on which contraction is not a valid inference. Such theories have recently been advanced by Beall, Brady, Field, Priest, Sylvan, and others. So like these are all big names in this area. All right. Explanation and truth conditions for conditionals. Among these theorists, some think that contraction's invalidity is to be explained by the arrow's truth conditions, typically because validity and invalidity in general are taken to be matters of truth conditions. For example, Priest argues that validity is the relationship of truth preservation in all situations, and this thought is also forcefully embraced in the work of Roulette, and also evident in Brady's work. While not universally endorsed, the thought is natural and common in philosophy. Example, why does it say that A and B implies B? Answer is because the definition of implication validity is truth preservation over all conditions. And the conjunction in which a conjunction is true, that is, the truth conditions for a conjunction, have it that A and B is true just if both A and B are true. The explanation falls out of the truth conditions and their role in validity. Likewise, the explanation for the failure of A or B's implying B invokes the truth conditions for the or, logical or, and the existence of situations in which A or B is true and B is not. And the same goes, according to target theorists, for contraction. Among such, let me drop the music a little bit. It's a little bit loud. Among such theorists, the dominant approach to truth conditions for the implication arrow invokes frames involving points, worlds, or world-like entities. We consider such an approach here, and we call the points worlds without worrying what they are. As a first approximation, let a frame be a set of W worlds, and let a model be a frame together with a relation, derivability between worlds and sentences of our language. So the derivability or assertion symbol, I guess that's derivability. I'm not sure what the turnstile is here. Turnstile can hold or not between any world and any non-logical atomic sentence, but is constrained for compound sentences. On the approach we're considering, it is these constraints that give sentential connectives their meaning. For example, here are constraints that give and, T, and fulsome. Was it fulsome? Yeah, fulsome. I'm losing it. Their meanings. So at the world, W, it is asserted or derivable, or it's true that A and B, if and only if at world W, W implies A and W implies B. Fulsome bottom. Yeah, thank you. I am starting to lose it already. It's what happens. So at world W, it implies that the truth of A, if and only if W implies A. And W does not imply fulsome for any world W. So the whole point is that in the world, things are true in that world. It's not false. It's not the false is in that world. And that's what it is to have a world. You have all the true things there for that world. That's what it means for it to be a world. That's how you understand what things are at that world. They're defined that way. It's not that they're the world has truths and falsehoods. That's just what that scenario is. And then you can look at that scenario and say how is it? And that's how you understand what's going on at that place. It's fine, Ra. Okay. It is sometimes useful to distinguish extensional from intentional connectives. Extensional connectives don't look across worlds. Whether a sentence built from an extensional connective is satisfied at a world depends only on what else is satisfied at that world. Intentional connectives, on the other hand, look across worlds. Whether a sentence is built from an intentional connective is satisfied at a world can depend on what happens at other worlds. Yeah, so it's like if I have a belief about certain things, that can be satisfied different ways the world may be. Okay? Because that's about my intentions, my beliefs. If I'm making a claim about this world, then it's about this world. Like, say I'm holding my hand up right now. That is not about my beliefs. That's about my hand in the world. That's either true here or it's not true here. If I have a belief that there are spies, there are multiple worlds where different people are spies, and so different worlds or scenarios could satisfy that belief. Losing it in less than an hour? Yep, it happens. Right, you overestimate my times when I don't say that, and I am losing it also. This happens a bit. Possibly, I think, is an example of an intentional connective. It depends. Yovko, it actually depends on the kind of possibility. Metaphysical possibility, and metaphysical necessity in terms of modals, you're talking about what worlds, so a necessity holds in all worlds. A possibility means that there is one world where that is the case. So that's not exactly the sort of thing. A belief, so like my belief has opacity, because you might say, okay, he believes that there is a mountain of gold. And that's a true statement, but there may not be a mountain of gold. Now, if I say there's a mountain of gold in this room, that's false, but I can still believe it. So there's multiple ways to satisfy mountains of gold. In possibility and modal logic, that's usually picking out a world where that is the case. Yeah. Diamond. Yeah. I got you the diamond, but it's it depends on your interpretation of the diamond. Yeah. You want to do Palestinian flag crochet? Fun. There you go. Yeah, knitting is fun. Oh man. Okay. So again, it depends if it's about the objects in the world is the extensionality. If it's not about any particular objects, and it can be satisfied by different objects and maybe even like different scenarios, like the whole world could be different, a whole different scenario, then it's intentional. This gets complicated, unfortunately. So, all right. So, and, true, and falsum are all extensional. So we're talking about how the way the world is at that place, not about what someone believes about it or something similar. Okay, since arrow will be used to express the strong T schema connection between A and truth of A, its constraint will take into account the relation between its antecedent and consequent across worlds. So arrow is intentional. Okay, so the arrow will be intentional. I don't knit. But knitting is cool. Okay, so at world W implies that A material conditional B if and only if for all worlds W prime that are grouped in big W, either A is not what the fuck is the word? I'm losing words. Is implied either A is not true at W or B is true at W. And that's a standard interpretation of the implication arrow. Either the antecedent fails or the consequent is true. What's the paper arguing for your context? This is about the Curry paradox. I don't normally do logic on stream, but it's Yovko's birthday coming up and they asked for it, so we're going for it. And it's short because I'm sick. And so it's only a few more pages. And so it's about Curry paradox and time, actually. I don't know where it's going. This is all set up still. Okay. So now we can define validity. An argument from a set of sentences gamma to a set of sentences delta is valid. So delta implies gamma if and only if in every model on every frame at every world W, such that world implies A for every A in gamma and world B implies B for some B in delta. Okay, so yeah, so it's validity if everything is true in the antecedent, everything's true in the consequent. All worlds where the antecedent is true, the if P, that's the P is true, then in that world Q is true. That's what it's saying. Yeah. You also listen to crochet snobbish Tunisian crochet. That's fun. Snobbish crochet. Okay, contraction, freedom, and non-normal worlds. But there is a problem, say the authors. As things currently stand, A implies B, implies A implies B. I mean, it seems like this would make sense. You're not actually adding anything new by saying if A, then B, compared to if A, then B, because it's the same if A. That is, contraction holds. The other principles used in the problematic Curry argument also hold. So such truth conditions can't be the whole story. They would force us to conclude falsum or explosion, however you want to say it, like everything is true, and thus every sentence, naked absurdity. Yeah, so the moon's made of green cheese. If it is to be contraction-free, the arrow must derive its meaning from some constraint that doesn't force contraction on it. For ideas to how this is to be done, we can look to frames developed for weak relevant and linear logics in which contraction fails. Here, the usual way cuts a distinction in W, namely normal worlds and non-normal worlds. You're going to be controversial. That's a hot take that Tunisian crochet is technically weaving. Yeah, I'm sure people are going to come after you for saying that, so be careful. Okay. Thus, we require our frames to be slightly more articulated, specifying a set of W worlds and setting a set and a subset, not a proper subset, just a subset of normal worlds. For any normal world, W and N, we constrain the assertion stroke, what derivability as before. But for any non-normal world, W, small w and big W, outside of N, we treat arrowed sentences differently. For our purposes here, we allow arrowed sentences to be satisfied or not by non-normal worlds arbitrarily. Okay, so we are going to allow some places in the universe to not have implication the way we normally think of it. Okay. If this is the only shift the authors make, however, we lose such important validities as modus ponens. Yeah, if you can't use your normal implication like mark, like just the arrow, you don't get modus ponens. Like fails. If P then Q, P therefore Q. Well, if that doesn't hold everywhere, then it's not a valid inference anymore. Okay. There will be non-normal worlds where A holds, A implies B holds, and B does not hold. Since whether A or B, if A then B holds, there has to be nothing to do with whether A or B holds anywhere. So we must also change our understanding of validity. The argument from a set of sentences gamma to a set of sentences delta is valid. So delta is derivable from gamma if and only if every model on every frame at every normal world W such that W implies A for every A in gamma, B drives W drives B for some B in delta. The restriction to normal world W in this definition ensure that by evaluating validity, we only look at worlds in which the arrow is well behaved. In particular, modus ponens is valid given this understanding of validity. Yeah, so you have part of the universe where modus ponens works and part of the universe where it does not. Why? I don't know. But we're going to do this. Crucially, however, contraction remains invalid. Although we only look at normal worlds in checking validity, those normal worlds themselves look at all worlds, normal and non-normal, in the truth conditions for arrow sentences. As such, it's possible that A implies B to hold at a normal world without A implies B holding there. This can happen if there is a non-normal world at which A and A imply arrow B both hold, but where B does not hold. Counterexamples to contraction somewhere thus rely on counterexamples to most ponens somewhere else. The distinction between normal and non-normal worlds allows us to keep these somewheres organized so that the counterexamples to contraction are sufficient to undermine its validity, while the counterexamples to modus ponens are not. Okay, so individually modus ponens works, but you can appeal to some weird part of the universe where contraction fails. This is strange shit. But okay, we can define places where this works. Okay, authors continue. Of course, if the invocation of non-normal worlds is meant to explain the failure of contraction, it is not enough to simply offer this kind of model theory. The explanation must tell us something about what the non-normal worlds are and why they are related to the arrow in the way that model theory takes them to be. Indeed, such a theory is offered by Graham Priest. The normal worlds are thought to be of as logically possible worlds. Non-normal worlds are thought of as logically impossible worlds. The idea that there can be physically impossible worlds, that is, worlds where the laws of physics are different, is a standard one. Such worlds are still logically possible, but just as some worlds have laws of physics different from the actual physical laws, so some worlds have laws of logic different from the actual logical laws. Our approach here shall assume that this, allowing for failure of contraction to be explained by invoking worlds at which logical laws differ, is broadly the right way to address Curry's paradox, and to explore how this approach adapts to a novel version of Curry's paradox with slightly different ingredients. Okay, so now you have to start to think is this actually sane? Can we define parts of the world where logic seemingly is not what we take logic to be? And if you're going to take logic just as a system of sort of connectives and syntax, sure. There's no problem. Okay, the music's still going. There's no problem with defining a sort of formal system of mathematics to be different. You can just go check it to see if it makes sense in some sort of it doesn't contradict itself, and that's okay. But does it make it sense about how it actually works in our world? It may not make sense at all. It may have really weird consequences, but is this a good idea? I don't know, but this is a major strategy people do. And so we're going to be leaving the realm of normal logic at this point because we can. We're going to partition the universe in the world of imagination versus reality. It is worse than that, Atom Fighter. It is worse than that. Because you can imagine a lot of things that are, the world could be different, different laws of physics. Wouldn't make a big difference. Say, I hold up my hand and now I held up, say, only 3 fingers. And then I did 5. And say I did that backwards. It wouldn't make any difference. The laws of imagination can still follow the laws of logic. This is changing the laws of logic. Yeah. So in your world, we have gravity, but in orbit around Earth, you would constantly float. Yeah. So those are different physical worlds, but they still make sense. In this one, we're changing what even makes sense. Yeah. So yeah, it's a little bit funky. All right. So what you can't really. It's harder to imagine things that don't make sense in our world, but that's why they're called impossible worlds. But it just takes a little bit more freedom on what you think might make sense versus might not make sense. Yeah, what's up, Birdbanes? Yes, you're importing different laws of logic. Okay, so that's what we're doing here. We're going to say in parts of the universe, we're going to call them impossible worlds, some weird shit happens, and it's really weird. It's not laws of physics are different. We're talking laws of reason are different. Laws of logic are different. And in those worlds, some weird things happen, namely this contraction fails. And that allows us to not get to the bad conclusions of the Curry paradox because it blocks a necessary step in the derivation. Okay. The meat, 2.1. The robust contraction freedom. First, note that it is not enough to avoid contraction for the implication arrow. Curry trouble arises if there is any connective, so a double arrow, meeting the following 3 conditions. So consequence relation, from A to B, we can infer A. So we've got small arrow implies double arrow, single arrow. Modus ponens. So this is consequences, modus ponens from A and B. We can infer if A, then B, then B. Yovko says contraction fails at possibles due to stuff in impossibles. Yes, that's right, Yovko. If I misspoke, I'm sorry. So contraction fails in our universe because of stuff that happens in the weird parts of the universe. That's right. Like UFO sightings, something you don't understand, you don't know what it is, must be something specific. So again, UFO sightings make sense in our world. People claim this, and technically there could be aliens that have that understand physics better than us, and so they hide real good. That's not, it's at a worse level. Things in logic, reason doesn't make sense anymore in those weird parts of the world. And so that's why laws of logic as we know them don't work out there. And so that's a little bit more freaky and scary. Okay. So we've got this contraction rule here from if A then B, then if A, then if A then B, then we can infer if A then B. For details, see Restall's. Okay, so we have a discussion of how these things lead to the Curry. Yeah. Lumen says, I'm learning that it's much harder to make bad puns in Twitch chat off a logic paper, which is probably a good thing. This is part of the issue with logic. There's a lot of background and a lot of technicalities. Now, there's all these reasons for why logic is this way. Because only certain systems actually work. You can only do so much in certain systems. Like once you change it, stuff starts failing and you don't get what you want. Yeah, so now we've got switch my musics again. People like to jump is the reason shortcut conclusions plug the discomfort of ignorance. That's true, Bird. But like you have to start treating the rules of like your reasoning as kind of arbitrary, and what happens when you start loosening them. Weird shit. And it's not like aliens. It's like normal things you assume to be true just aren't true anymore. Yofko says, worth noting that we say worlds, but there are different understandings of what those may be. Yeah, depends on your understanding of modality, absolutely. For now, maybe just some kind of model or set and abstraction for our purposes. It's not fine to get into particular metaphysics, ontology of it. Yeah, but you do have to understand that... I mean, the point here is that there's weird parts of like reasoning that are going to fail somehow. Luminance says, curry is so much tastier when it's temporal. Yes. Strange Dust. Does the existence of me imply the existence of... yes, it does. It's just in a non-normal world. That's right, Strange. Yeah, the goal here is to remove contraction but keep modus ponens. That's exactly what they're attempting to do. Yeah, the maybe agree. Exactly, Ra. That's exactly, Ra. Was it Nozick logic papers? I missed some stuff. If I miss something, let me know. I'm a little off today because I'm sick. So, yeah, and we still have the T schema, but they're using the double arrow T schema because that's modus ponens. There's just this consequence relation, and then we've got the double arrow consequence relation. Consequence relation is the stuff that happens in normal worlds, and then the contraction one with the double arrow is ones that can happen in non-normal worlds. Alright, so from the consequence and the consequence involving the T schema, the double arrowed T schema follows. And the curry proof in the section 1.1 for the single arrowed consequence can simply be repeated as it is for the double arrowed for all the other stuff. Below, they present a connective that, at least prima facie, seems to satisfy the T schema, most ponens, and contraction. We then argue that a friend of non-normal worlds explanations of the sort mentioned in 1.2 ought to acknowledge the non-normal times to address this threat. Okay. Temporal curry. So we're finally getting the spiced up time. Sentences are not just true at some worlds and false at others. They can also be true at some times and false at others, even within a single world. To accommodate this, we follow Kaplan and expand our models. We now take our models to specify a set of worlds, set W of worlds, and a set T times. Before we divide the set of worlds W into the normal worlds N and the normal worlds N and the others, the non-normal worlds. Now we can specify truth conditions for our connectives almost as before. The difference is straightforward. Sentences are not true at worlds, but instead true at world time pairs. For all of our above connectives, the truth conditions change only slightly. They now carry an idle time parameter. For example, for any specific world W in the set of worlds and a time T in the set of times big T. So you've got a world and at that time. Then you've got if A and B, if and only if is implied, if and only if for that world time, A is true and B is true at that world and at that time. The condition material implication, or the implication arrow, is perhaps more of more interest, but the same idea implies. For normal worlds, because that's the normal one, not the double arrow, I guess. Yeah, so it's just saying either the antecedent is false or this consequence is true, which is how you can get the truth of an implication arrow. But that's fine. And that's the normal definitional stuff. You're just doing it at a world and at a time, then that thing holds. As before, at non-normal worlds, the implication symbol is not constrained for material implication. Yeah, I can't remember what exactly calling this, but for a world, it makes it true at that time for those implication sentences. Here, this lack of constraint extends to all times. Yeah, so if the world validates it at that time, then the world and time, then it's valid for those implications at that world and time. Okay. If this were all there was to temporal worlds, they would not be very interesting. They come into their own when we consider connectives that shift the time parameter. By analogy with the extensional-intensional terminology to describe whether a connective shifts the world parameter, we can draw a distinction between extemporal and intemporal connectives. All of our old connectives are extemporal, but intemporal connectives allow us to use the structure that temporal models provide. The most familiar intemporal connectives are unary connectives studied by Pryor, often written FGP and H. Here we skip these to explore the behavior of a binary intemporal connective, which we write, only for the lack of obvious better notation, as a short map arrow. So there's a little line on the arrow. Informally, arrow, short map arrow B is read something like whenever A, B. So instead of if A then B, then whenever there's A, then there's B. So it's you can do this, and this is a long-running tradition actually across the history of logic. It goes back to Islamic logic. They talk about this, that you can have temporal quantifiers. So you don't just say if this, like if it's the case in this world, you say when this is the case at a certain time. Okay. So then you get this line here that basically, I guess, uses this temporal whenever. So at the world and time, whenever A, then B, if and all and only if for all times at in the set of times, if world at that world at some other time, A is true, then at that time B is also true. All right. So despite the intemporal of the map extension, despite being intemporal, the implication is extensional. Its range of truth values at a world W does not depend on any world beyond W. You love temporal quantities, yeah. So another shot of drugs? Not yet. I mean, you have to wait 4 hours, and I took it only a half hour before stream. So I took it so I'd be as drugged up as possible during stream. But I appreciate your concern, Ra. Okay, but now trouble is brewing. Called a world time pair WT, a normal world pair just if W is in the normal worlds. Presumably want it to be the case that A implies the truth of A, this map thing at the times. So that would mean it's true of A implies A. Are logical truths true at all normal world pairs? Indeed, as far as we can see, any motivation for the T-schema's validity at worlds is equal motivation for its validity at times. Just as it's very difficult to imagine a world at which A holds without the truth of A holding and vice versa, so too is very different for times. Yeah, so if A is just true and you change the time, what does that matter about saying A is true versus A? If it's A is true now and A is true then, why would the truth of A change? Like what you're calling the truth of it. But now the trouble bubbles to the surface. In particular, notice that given the truth conditions for the map implication, that's the temporal one, we have both the temporal modus ponens and the temporal contraction. Here mixed with the temporal T-schema, we have ingredients for explosive curry. So the curry is giving you bad explosions. This is a temporal curry paradox that's as explosive as a standard non-temporal relative. Yeah, that's right. Whenever A in quotes is true, then A, and vice versa. Yeah, that's they're calling that just T-schema here. Yep. Doesn't change without a stochastic sequential process. Well, in some sense, Sock now, yes, but we're talking logic here. So the jumping between different times is kind of assumed in the background. So we're not talking physics here, because then we would have to get directly from one temporal spot to another using some law of physics. That's how the real world works. In logic, we're just saying, look, if it was true here and it's true there, it's just true. Like, we're just saying it's true at all times. We're not actually questioning how you get from one time to another. If you're just saying it holds across time, then it just holds across time. We don't need a process in logic. In some sense, logic doesn't purposefully leaves that out because how things work in logic is, well, how it works is a matter of physics. That's not logic. This is describing the structure of how we think about stuff or how physics works, the constraints physics works within. And how that actually happens is a matter of physics, but the logic isn't worried about the process. It was true that UFO was 15 some time ago. Now it's not true. Well, I mean, it depends on your perspective of time. You've been 15 before, you've been 15 in the future, you were 15 in the past, or whatever it is. But like, if you're looking at like block time, Yoko is 15 at a certain time. Like, yes. Now, was Yovko exactly 15 for all time? No. But the Yovko is 15 at time T is true across all time. So it depends on how you start defining things, which now that's exactly where we're at, where we're getting trouble. Okay, the bite. Non-normal times. Since this is substantially the same problem as Curry's paradox for the regular implication, we think it should receive substantially the same solution. In short, the temporal implication obeys the given truth conditions at most world time pairs. However, there are world time pairs, called them abnormal, at which the temporal implication fails to conform to the given truth conditions. Perhaps as with the normal implication, behavior of temporal implication is arbitrary at abnormal pairs. Such abnormal pairs involve non-normal times at which laws of logic fail. Yovko says, well, that sense is supposed to be I think it's called an A sense or something like that in A versus B time theories. Could be. Like, unfortunately, my recollection of I don't know a whole lot about the time theories, first of all, and my recollection of the stuff is shaky at best at the moment. This is one of the reasons I want to work on a theory of time, just as an opportunity to learn the metaphysics of time better, because it's not anything I've ever looked at in the past, because I was like, that's too hard. But now I'm just like, fuck it, I don't care. But like, yeah, so I mean, you may be 100% right, I just don't know at the moment. This is Matthew PhD. I don't normally read this sort of stuff on stream, but it's Yovko's birthday, so we're doing a birthday thing. There's like an at time T, Yovko is 15, which would not exchange across truth value across them. Exactly. So what do you actually mean when you say something's true? Do you have an implicit time value associated with it, or do you mean it like a logical truth, like across all times and all worlds? And a lot of times people say, well, I meant when I said something's true, like it's raining or whatever, I meant now. A lot of people mean now when they say stuff. Emphasis on the ick of logic, Vipers, yeah. So I don't blame you. It's like you have to care about some of the background issues here to care about the paper. Yeah. You know, it's not so clear actually what's like, if you it's definitely hard to reduce math to logic. Like, you probably can't do that. So it's not so clear exactly what is fundamental. Yeah, logic does act upon it. That's fair, PhD. Okay. So the bite is more than that there be some world time pair WT that is abnormal and having a non-normal time. The bite is stronger. Every world, and hence every normal world, including this, our actual one, features in some abnormal pair. Suppose otherwise. Fix a world W and suppose that for all times in the set of times, the whenever connective, the whenever A implies B, obeys the given truth condition at that world and time. Then we have Curry trouble at that world. Consider a Curry sentence C equivalent to the truth of C temporarily implies falsum. And that's explosion or any sentence you want. Suppose at the world and that time, C is implied. So you've got the Curry sentence. Then for all T prime in the set of times, and if a world at that other time, the truth of the Curry then implies the truth of falsum. Since you're not supposed to have falsum, like you're not supposed to have explosion in all worlds, for all time T prime, then it must be that the world at that time did not imply the truth of Curry for all T. But then you have your counterexample to the T schema. This cannot be. Hence, for all times T, we have the world and that time does not imply the Curry sentence. If we were to avoid a counterexample to the temporal T schema, it must be that for all T, for all times, world and time do not imply the truth of the Curry sentence. But then the material implications, truth conditions, you have a problem, because then the Curry sentence implies the Folsom, and then you're back to where you started, really, where the Curry sentence implying the Folsom, and then that is impossible too. Ugh. Yeah, exactly, Unreal Brian. Like, they've turned into, well, Russell basically thought he could, and then it blew up, unfortunately. PhD, I've been trying to get into the foundation and the predicate calculus, definitely a puzzler. Yeah, I mean, if you're interested in it, go for it. There's a lot of stuff that gets said on this. A lot. Yeah. So the philosophical rub comes out when considering the actual world. As above, for any world, there must be some abnormal pairs in which the temporal implication does not obey the given truth conditions. Consider the actual world, the little at symbols, how they say this, and let the non-normal world times be those times for which the at and time is an abnormal pair. By the argument above, there must be non-normal times, but this is philosophically awkward. It is much harder to make satisfying philosophical sense of non-normal times than it is of non-normal worlds. Why? That's interesting. See, this is part of the reason I want to write a metaphysics of time. We can write a times that are not so normal. It's hard, though. You think you're in the actual world, but you have to also think that time works in the actual world the way you think it does. And this is the intuitive thought, I guess, that they are pointing to here. That in the actual world, you think time works as you expect it to. So if you are now trying to mix actual world with non-normal times, that seems very awkward. How do you actually separate out the way the normal world works with non-normal times? And that's really the interesting bit in this paper here. This is where they called the bite. You can see it up here, the bite. And this is actually the most interesting bit. It's that if you're going to make pairs of things that include the actual world and weird times that don't follow reason, really, then how is that the actual world? World is kind of abstract and can be basically shoved into some kind of neither under interpretations. Times, however, don't really work like that. Yeah, and that's the whole point, is you have to start that's right. So the issue is that we're talking about the actual world here. And so once you start talking about the actual world which we all experience, then it's a problem, because it does have to satisfy our sort of basic understanding of what the world is like. But then you're saying, well, we're pairing it with non-normal times. Well, time seems to be part of the actual world, and doing that is problematic. So yeah. So times, however, don't really work like that. Well, why? But this is the issue, exactly. Okay. Non-normal worlds we call are worlds where the actual laws of logic do not hold. Since worlds are unfamiliar and odd sorts of places anyhow, it is not so challenging to suppose that some of them fail laws of logic in this way. But if abnormal pairs are pairs where laws of logic do not hold, as they must be, then there must be times at which the laws of logic fail in the actual world. And this is the problem, is that like the laws of logic fail in the actual world with these weird times. This, we think, is harder to swallow. There is no modal cushion between us and the failure. It is only a matter of minutes. It may be many minutes. It may be all of the failures are tucked away safely in the past or far for the future, but still they must be there, if not now. This failure is serious. As we saw before, for contraction to fail here, modus ponens must fail somewhere. Thus, there are times at which modus ponens fails in the actual world. When are the non-normal times? That is a fantastic question, Yovko. But that is the point, is they say, I mean, I don't know if you wrote that before this, but that's the issue. It has to happen at some point. If you're going to make pairs of times and worlds, then you're going to pair the actual world with some of these non-normal times, and that seems very strange. Unreal Brian says, the sun is the same in a relative way, but you're older, shorter breath, and one day closer to death. Damn right. Yeah. Okay, possible responses. I wonder how I'd respond to this. Well, I don't use this sort of non-normal world strategy to deal with these paradoxes. So I would just say I don't like this strategy of making non-normal worlds to prevent contraction. I don't think contraction is the way to go. I think considering it as a discovery may be cool. Yeah. Well, that's the coolest part of this paper. That's why they wrote this, as far as I can tell. It's that if you start breaking up times and worlds in this way, then you get this very weird combination, and that is a cool result as far as logic goes. Okay, possible responses. Of course, one can simply bite the bullet and admit that there are non-normal times. Perhaps this is a discovery rather than a reductio. Certainly, when paradoxes are in the air, one has been mistaken for the other before. Yeah, but if this is the right way to understand the situation, more needs to be said to assuage the initial awkwardness. Even those of us who are prepared to go along with non-normal worlds feel some difficulty allowing for non-normal times. A story about why logical laws might change over time, analogous to the way they can be taken to change over worlds, would be a great help to resolve this difficulty. You would take it they did more as a reductio. Yeah, you can see right here is that they're waxing philosophical on what they're doing. Like I said, these are competent philosophers as far as I know. I've seen J.C. Beall before, his stuff, and I've seen him talk. So it's like these are competent people. Now they're waxing philosophical. It may be a reductio. There may be other stuff to do. Another possibility would be to attack the analogy we have exploited between worlds and times. For example, perhaps there is some reason why there should be no extensional intemporal connectives like the temporal implication, despite the presence of intentional extemporal connectives like the regular material implication. Regular implication, yeah. I don't know if it's material here. It's not material. Sorry, I keep saying that. We don't immediately know what such a reason could be. However, if there were some reason that anything like the temporal implication had to be intentional, we could invalidate contraction at this world by invalidating modus ponens at some other presumably non-normal world. Then there would be no need to invoke non-normal times to avoid temporal curry. Again, though, more would need to be said to make this plausible. To sum up, if the failure of implication contraction is to be explained by implications relying on worlds at which logical laws fail, then the failure of the temporal implication contraction ought to be explained by temporal implications relying on times at which logical laws fail. At least prima facie, however, allowing for actual times at which logical laws fail is quite awkward, more awkward than allowing non-actual worlds at which logical laws fail. So the advocate of non-normal worlds must either 1. Explain why they do not advocate for non-normal times, or 2. Explain why non-normal times are not as awkward as they first appear. We see no obvious way to do either of these, and so we leave this dilemma, at least for now, a dilemma. And that is this paper. Hooray! Yeah. Okay, so now we get to rate the paper, and I know this was logic, and I don't normally do logic, and it's a lot of jargony stuff, but you can understand. There's paradoxes that we come up with. There's ways we try to fix them by, doing some fancy stuff with logic, but then all of a sudden you say, well, okay, look at time. Logic still has to hold across times, and then the way you were trying to fix the paradoxes no longer works once you consider time. You get another version of the paradox. Energy says a knife, navel gazing, brain dance, a yay and a meh. Peach Tea gives it a knife. Yeah, I mean, that's what analytic philosophy is. It's fancy argumentation, trying to reason through how we're supposed to even talk about this stuff. And that's what it is. Like, are we supposed to come up with non-normal worlds? These are fancy ideas where the normal laws of logic don't work. We don't live in the non-normal world, so it seemed like a safe place to hide all the problems. But once you talk about times, then you have non-normal times, but that could happen for the actual world, and that really seems weird. Why can you have non-normal worlds, but not non-normal times? And that's where these authors got in. Yovko gave it 4 yays, a brain dance, and a knife. I think Yovko liked the paper. Yeah, this is a straightforward idea. Like I said, they started off with the standard responses to the Curry paradox. They threw in time, which seems a reasonable enough thing to do. And they showed that the standard responses have a bad problem when time gets thrown in. And so it's, I'm with, like, this is not bad as far as this sort of area goes. So I'm on board with Yovko mostly. So this is what I'm gonna give this Nog Knife, because it's a lot of argumentations. Nog Naval, you have to care about this shit. Yeah, and that's fair. Like the idea that like logic isn't for everyone. You need a lot of background to understand what's going on in some sense. That's why I don't do it, because I'd have to sit here and explain all the symbolism and kind of like these systems, and you need a little bit more familiarity. Emil says, knife, I don't have the background to offer much else. And that's the issue here. And this is why I don't normally read logic. But I can try to explain kind of, okay, we have the real world, but then at some time, everything that we think follows logically doesn't. And that's a problem. And if that happens, like, well, that's weird. So that means you can't use a system where that happens to try to solve paradoxes. Sockno gave it a yay or Boris and brain dance. Yep. Cool. Peach Tea also find interest a yay, but also slicey dicey. Yeah, that's cool. Thank you for the yays. Thank you for the ratings. Yeah. It's slicey dicey, a little navel gazing because you have to care about logic, but like it's good paper. Now you really have to care about the this approach to the Curry paradox. That's all. Yep. Maths. Yeah, exactly. You listen, I love logic. Well, you have to also love trying to mess around with logic and try to come up with new ways to describe stuff. I do this all the time, actually. I have papers. I'm not as much of a logician as these folks, but I'm coming up with stuff that's really quite in the neighborhood sometimes. You of course have a bit of math phobia, but for me logic feels different. This is the same with me, actually. Enough to some common math. I'm particularly thinking about school stuff pre-academia. Yeah, I don't do math at all, but I do logic just fine. Yeah, because I come at this from the metaphysical side. I'm thinking about this, what's implied, what follows from what. I'm thinking about this very philosophically, and then I can build the systems from there, and that has overlap with math. But I just do it from the completely philosophical side. Luminance, give it a knife and a brain dance. Thank you. Peach T says logic is fun to play with, but it takes time to understand how to play the game, time and focus, and diagrams. Absolutely. And I write on diagrams too. Part of my area.